Hi everyone, welcome to Integral Calculus. Today we explore lesson 7.5, strategy of integration. You will learn how to best approach each integral. Let's begin with the first one, integral of x over x to the 4 plus 2 dx. This is a rational expression. However, we cannot factor the denominator. And so it is not possible to use partial fraction. Notice that we can write x to the 4th at x squared to the power 2. So the strategy here is use the u sub and set u equal to x squared. Integral x sine square x cosine x dx. We know how to integrate sine square x cosine x dx. So that can be dv, the remaining part. U, so u dv, integration by part. Oh, look at the integral of x squared over square root x1 minus x squared dx. We have a radical root of 1 minus x squared. Ta-da! We use trig substitution. Trig sub x equal to sine theta. Next integral of x minus 1 over x squared minus 4x minus 5. That is a rational expression. Let's factor the bottom. X minus 1, the bottom can be factored into x minus 5, x plus 1 dx. Oh, so we can factor the bottom. Then we can use partial fraction. Partial fraction. Set x minus 1 over x minus 5 times x plus 1 to be, well, decompose it. A over x minus 5 plus b over x plus 1. Okay, so far, make sure you look for specific strategy. As long as you can classify the integrand according to its form, then you'll be able to know which strategy to use. Classify integrand according to its form. Okay, let's move on to more. Now we have the integral of arctangent x over x dx. Yeah, what would be the best way to approach this one? We can take the derivative of arctangent x. And if we can take the derivative of that one, then it's best to split this into two parts. Integral of arctangent x times 1 over x dx, and let arctangent be u. 1 over x dx be dv. So integration by part. Yeah, sometimes just manipulate the integral, and you'll be able to do it. Integral 1 over 1 plus e to the x dx. No. This one is kind of tricky though. And the tricky part here is that it is none of the form above, right? We cannot classify this. But then we know that the derivative of e to the x is e to the x. So that would help us somewhere. So sometimes we can just let u equal e to the x and give it a try, see what is going on. When you let u equal e to the x, you will see that du is ex dx. So what we have here is integral of 1 over 1 plus u. And then the dx is du over e to the x, but e to the x is u. Ta-da! Oh, what is this one? In the bottom is a product of two linear factor. So the next step to do is integrate using partial fraction. Yay. Same thing for integral of root x plus 4 over x. We can let u equal to root x plus 4. And you see that du is 1 over 2 root x plus 4 dx. So the integral here will become integral of u over. You can work out the square root here. So if you square both sides, then you see that u squared is x plus 4. So that means we can find a substitution for x. U squared minus 4 equal x. Okay. So this is the u squared minus 4. And then the dx is going to be 2 root x plus 4 du. Well, root x plus 4 is u, so it's going to be a 2u du. We can factor out the x squared plus 4. And so that would be integration by part. But before you do integration by part, you have to do the long division because the power on the top is the same as the power on the bottom. Integral 2u squared over u squared minus 4 du. Right? Integral x plus 4 over x squared plus 2x plus 5 dx. The integrand is a rational expression. However, we cannot factor the bottom. So we just have to notice that if we take the derivative of the bottom, x squared plus 2x plus 5, we would get 2x plus 2, which is 2 times x plus 1. So we can split this into two different integrals, and that would help us out. We can split this into integral of x plus 1 over x squared plus 2x plus 5 dx plus the integral of 3 over x squared plus 2x plus 5 dx. If we cannot factor the bottom, right, we can always do a complete in the square. For this one, complete the square. And that will get us somewhere. for the integral of 1 over 1 minus cosine x dx, we can multiply the integrand by the conjugate of 1 minus cosine x, which is 1 plus cosine x over 1 plus cosine x dx. And then from here, things will get better. Okay, a few more to go. Integral tangent theta over secant square theta d theta. When we run into something like this, it is best to simplify. So all we have to do is simplify. And that will give us the integral tangent is sine over cosine secant square 1 over cosine square. So this would give us the integral of sine theta over cosine theta multiplied to cosine square theta over 1 d theta, and that is integral of sine theta cosine theta d theta, which we can do. Yeah. One more. When we deal with absolute value, we just have to be careful. The definite integral of an absolute value is always positive. My suggestion here is sketch out the integrand. We know this is the graph of e to the x 1, e to the x, e to the x minus 1. You just have to shift it down by 1 unit. And this is what it would look like. Fx is e to the x minus 1. Oh, from -1 to 2, right? Here come -1. And here come 2. We have two areas, one below the x-axis and the other one above the x-axis. Both of them has to be positive because of the absolute value. So once we sketch out the graph, oh, we know. Split this into two different integral. The first one is the integral -1 to 0. And put a negative in front of e to the x minus 1 dx to make the integral positive. The second integral, well, it's already above the x-axis. That is the integral from 0 to 2. We don't need absolute value anymore. Ex minus 1 dx. Yay! And just use the normal antiderivative and we can get the answer. Thank you for watching. I hope you found the content useful. Please like, subscribe to help the channel grow. I will see you in the next video.